Hello Algebra 1, I've created this video lesson for B block, but it's appropriate for anybody who needs to catch up on or review how to find the linear equations that are buried inside word problems and then how to solve those linear equations. As I've explained in class, even to B block, they are a couple of days behind the other blocks but are starting to catch up. One of the things I explained is that when you look at a word problem, there are particular things you're going to look for in the word problem to try to decide which type of linear equation, linear form you have, or that's most appropriate. So for example, a slope-intercept form, which is y equals mx plus b, is most appropriate if you can see in the word problem a starting amount and a rate of change. A perfect example, you know that you have a baby puppy and you're there the day that it was born and you know how much it weighed. Let's say it weighed 1.5 pounds. And you know that it gains half a pound a week. Well, there, in that story, you have a rate of change, half a pound a week, and a starting amount, 2 pounds. By contrast, standard form, which is ax plus by equals c, is the most appropriate situation when you have something that I've called a budget. I'll give you an example in a minute, as well as two choices about how to spend that budget. And lastly, point slope. Point slope tends to be the easiest to work with when it's written as an equation, and often for many students is the hardest to work with when it's a word problem. Let's talk about how you get a word problem into the form y minus y1 equals m times x minus x1. It's one of two situations. Either you have what I'm going to call a data point and a rate of change, or you have two data points. Let's go back to the puppy example. The data point. Maybe you weren't there the day that the puppy was born. Maybe you first see the puppy when it's 2 months old. Maybe at that point it weighs 7 pounds, let's say. But you do observe that it continues to grow at 1/2 pound per week. Well, you don't actually have its starting amount, its starting weight. You just have a data point and a rate of change. So you can create a point slope equation that would let you predict how big that puppy is going to be in 2 months from now. Also, you might have only two data points. Maybe you don't really know this puppy that well. Maybe it belongs to somebody else and you've seen it twice. Once when it was 8 weeks old, and at 8 weeks old it happened to be, like I said before, 7 pounds, and then you see it again 3 months later and maybe now it's 16 pounds. So those are those two different data points that you have, and from that, and I'll show you how in a minute, you could create a point slope equation. Let's go through this one by one. This question here, turning word problems into linear equations, question 1, the one about Bella at Mother's Day, this comes straight from your homework. It's the first page of your homework, and you need to decide which of the situations, which of the forms is most appropriate for this word problem, this story. And I'm not going to find the answer for you. I'm just going to point out that some of us have already said in class, let's catch everybody up to the same place. 18 inches tall. Well, that's the starting amount for Bella's mom, so that's what we're going to go with. We're going to say that it's born at 18 inches tall. That's fine. So that starting amount here, and then 1/2 inch per week. That's how much it's growing. That's the rate of change. So you have a rate of change and you have what I'm going to call a starting amount. So based on those two facts, you now have the general form y equals mx plus b. By comparison, I gave you this second question here, the peaches and blueberries, and in this case, I'm going to say you have a budget. Your budget is you have $12. There are $12 in your wallet, you're looking to spend it, and you have two choices in the store of how you want to spend it. You want to buy some peaches, you want to buy some blueberries. You don't know at this point how much you want to buy of each, but you do have at least a budget and two choices. Okay, so for this question, and I'm going to go back in a second, this I'm going to call the peaches blueberries question, and going back, this one, the Bella's mom's plant question, all I've done is tell you which form I'd recommend that you write your equation in. In this case, I'd say y equals mx plus b, and the second one, I'd suggest ax plus by equals c. But you still have to do the work. Go ahead and write that linear equation that models both of these situations. I'm going to move on. I'm I'm not going to go to question 3. I'm going to jump ahead to the bottom of page 1 to question 6. This is the story about the rent for a one-bedroom apartment. In this situation, you do have a rate of change, $27 per year, like indicated here. But you don't have the original price for the rent for that apartment. You have the price in 1997. That's just a data point. That's like you're walking down the street and you see that dog and it belongs to somebody else and you observe that it's 32 pounds. Well, that doesn't tell you how much it weighed when it started out with that family, let alone when it was first born. But you do have a data point. Just like here, you don't know what the original rent was for that apartment, but you have one fact that in 1997 that was its rent. You should be able to put this together with the rate of change and plug those pieces of information into this form and come up with an equation. But rather than show you how to do that one, I'm going to show you how to do one on the back side of the same homework sheet. At the top of that homework sheet is question 1. Now your question 1 has slightly different numbers, and that's good. I don't want to solve your question for you. So I don't think we're talking about 1994 and 2006 in your question, but it's basically a question about vacation trips in the United States. Let's look at how we would solve this. First of all, there are 2 questions. First, write the linear equation. Second, predict the number of vacation trips later in the story. Okay, one step at a time. The linear equation. Well, remember that when you have, as you do here, a rate of change, 24 million per year increase, and one data point, in 2002 there were 955 million trips. In that case you want point slope, which is y minus y1 equals m times x minus x1. And here's that green value for m, it's 24, and the x, well, this is a crucial point. The data point is made up of 2 values. In this case, it's 2002 and 955. That will always be true for any data point. You're going to have 2 values. One of them is going to be independent, the other one dependent. And you have to stop and think, which one is independent of the other? So in this case, are years independent of trips, or are trips independent of year? Well, it can't be the case that the year depends on the number of trips. It makes much more sense that trips depends on the year. So trips is the dependent, it's the y. Time, year, is the independent one. So it goes with x. Okay, so in place of x1, I'm going to put 2002, as I did there. In place of y1, I'm going to put 955 coming from here. And like I said before, the slope, m, is 24. I got that up here. Okay, so this right here, that's my answer to question A. I've written a linear equation, and that one right there is perfectly appropriate. Now let's look at question B. Predict the number of vacation trips in 2013. All I've got to do is put 2013 into this equation. The challenge is to figure out, where do I put it? Do I put it in place of y or in place of x? Those are really the only 2 places I can put it in this equation. Well, maybe just by numbers it looks obvious, but it should make sense in terms of logic. 2013 is a time, just like 2002 is. So put it in place of x there, and look what happens. I'm going to end up with this. Y minus 955 equals 24 times this difference, 2013 minus 2002. Well, that difference is 11. So I've got y minus 955 equals 24 times 11. Well, 24 times 11 is 264, I believe. I did this in my head, so there's every chance that I made a mistake, and correct me if I'm wrong. If y minus 955 is 264, then y is 1,219. Now, the crucial point with a word problem is to remind yourself, 1,219 what? Well, let's look back here. Y came from, oh yeah, the units here are millions of vacation trips. So it's 1,219 million vacation trips. Another way to say it is 1,219,000,000 vacation trips. An awful lot of vacation trips. Let's move on to one last example. Question 3 on the back side of your homework sheet. Again, I've changed the numbers. In your question 3, we're not talking about 1968, and we have a different average car price. But still, in both cases, it's a question about the average car price in the past, in some time that's near the present, and then your question B is to predict that price in the future. All right, let's go through this step at a time. In this case, I don't have a rate of change, but I do have 2 data points. Kind of like I said with the dog, where you see it when it's a couple of months old, and then you see it a couple of months later. Well, in this case, you see the car in 1968, and then you see another car in 2010. So, to put this as a linear equation, remember if you have 2 data points, you want point-slope form. Point-slope form involves slope, so you've got to find slope. From 2 data points, use that old formula you remember from last month, y2 minus y1 over x2 minus x1. When you do that calculation, you'll find you're going to end up with 24,400 over 42. Make sure you realized that the y's, the dependents rather, are the dollar amounts, the prices, and the x's, the independents, are the years. So $24,400 higher after 42 years, that turns out to be, if you put that into a calculator, that division turns out to be $580.95, roughly $581 per year is how much the price of a car went up. Okay, now you can put M into your point-slope equation. Remember, there's your general form for point-slope. You put 580.95 into that. That's as far as I'm going to go in helping you. From here, you should be able to figure out what to put in for y1 and x1. You actually have 2 different choices, but that's all I'm going to tell you. And you should be able to go forward and go ahead and tell me not only this, but you should be able to figure out where to plug 40 in and be able to tell me what the average price of a car would be when you're 40 years old. Now, your homework assignment, as you know, is to finish the front and the back of that double-sided set of word problems and bring that to class after the vacation. Look forward to seeing you then. That's all there is for your homework. I know we had talked about there being 2 assignments, but that's all there's going to be. So I'll look forward to that, and I hope you have a great vacation.